Well, hey guys, welcome back. We're going to continue working on our review sheet for Unit 5 review, multiplying fractions. If you've already watched the front side, you've definitely collected 4 letters. Let's spell a word, which you're going to submit for your name, with your name for a prize. I'm going to be doing the same thing on the back side, so continue to watch. This will be a completely separate opportunity for you to be able to earn a prize. We're going to go through this rather quickly. Because it is the same concepts that we just did in the front, but these are a little bit more complex. So I hope that you are ready, paying attention, and ready to take charge of your education so that you do awesome on our Unit 5 test on Tuesday. So number 9 says, Miss Levy is making a sweet potato casserole for her family. Delicious. Good call, Miss Levy. The recipe calls for 3½ cups of mashed sweet potatoes. Miss Levy has a big family, and she decides to make 4 4/4 times as much the recipe calls for. How many cups of mashed mashed sweet potatoes will Miss Levy need for her casserole? Wow, I'm impressed. That's a lot of sweet potato casserole. That sounds good. But my family would probably eat it too, and we don't even have a large family. I just really like sweet potatoes. All right, anyways, cubes. I'm going to unwrap my word problem. So first of all, I see 3½ and I want to not just circle the number, but what it represents. In this case, it represents the recipe calls for 3½ cups of sweet mashed potato. Then I also see this number 4 4/5, and it says she wants to make 4 4/5 times as much as the recipe calls for. So she's wanting to make this recipe and 4 4/5 times as much. The question says, how many cups of sweet mashed potatoes will she need for a casserole? And my operation word, what is my operation word? Oh, times as much, which tells me that I'm going to multiply. So times as much, I'm going to multiply the amount for run recipe, which is 3½. And she wanted to make 4 4/5 times as much. So I'm going to take these two fractions and I'm going to multiply them. Now, I know that when I'm multiplying improper fractions, I can do the area model. If I really like to break it down by the value of each digit, I could draw my little box 2 by 2 and multiply my length times my width, and add together my partial products. Or, which seems to be the more favorite, is to turn it into improper. So I would do my whole number times my denominator, add it into my numerator. So 3 times 2 is 6. So I'm going to add 6 halves with the 1/2, and now I have a total of 7 halves. So 3½ is equivalent to 7 halves. I would do the same thing here with 4 4/5. Whole number times my denominator, add it into my numerator. So 4 times 5 means I'm adding 20 fifths with the 4/5 that I already have. So 20 fifths plus 4/5, now I have, 24 fifths, not too difficult. Now, I can easily multiply my my denominator times my denominator, so I'll just do that very quickly. Now this one, some of you friends might like to rewrite it going vertically and write 24 times 7. Remember, largest digits on top is the easiest way. Some people can multiply it this way as well. 4 times 7 is 28, so you drop down your 8 and regroup your 2. And then 7 times 2 is 14, plus 2 more is 16. And then figuring out how many times can 10 go into 168? Well, I know that 10 can go into 160 16 times, because 16 times 10 means I'd get rid of 160 tenths, which would leave me with how much? 168 minus 160 is, right, very good. Good job. Is 8 tenths. And so then I just want to, again, be flexible with my numbers. This is a possible answer. This is a possible answer. But what else do I know about 6 tenths? Very good. Hopefully you recognize that 6 and 10 are both even, so nothing else. They can both be divided by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. So in order to make the recipe for her large family, she's going to need 16 4/5 what? What's our unit of measurement again? Good, cups. 16 4/5 cups. So 3 possible answers. All 3 of these have equivalent value. But again, you don't know the way it's going to be represented. If it's multiple choice, one of those would work. If it was select all of those could work. So we've got to be flexible. Same thing, I'm going to look at number 10. Number 10, Tanea. If I could not read that name, I would just call her T. T-dog, T-girl, whatever. We're not going to waste our time on names. So Tanea rides her bike 3 1/3 miles on Saturday. On Sunday, she rides 6 2/3 times further than she had on Saturday. How far did Tanea ride on Sunday? So here I see Sunday, and it says on Sunday she rides 6 2/3 times further than Saturday. So times further is going to definitely be my operation word, which tells me to do what operation? Okay, pretty simple. Tells me to multiply. So I'm going to take how much she rode on Saturday and multiply it by how many times further she rode on Sunday. So this one I'm not going to do with you. It's going to be the same concept though. I want you to take and multiply your whole number times your denominator and then adding it in with your numerator. Same thing here, whole number times your denominator and then adding it in with your numerator. Once you get that final answer, you're probably going to have a fraction greater than 1. You will have a fraction greater than 1. Take it back to that mixed number. How many times can it go in? And go from there. So I'm going to move on from that one, but if you're collecting letters, I hope that you'll solve this. But if you're collecting letters, let's see, what letter do I like? I like the letter T. So if you'll write down the letter T, that is going to be your first letter for the word on this side. Let's look at number 11. Number 11 says Guido, again, if you don't know the name, it's just G. G multiplied 505,786 by a number. His product was, whoops, that says lesson? It should be less than, wow, is less than 505,786. Select all the numbers that Guido could have used when multiplying. So if I'm unwrapping my word problem, I know he's multiplying 505,786 by a number. Does not tell me what the number is. But does tell me his product, which means he's multiplying. His product is going to be less than. So if I want it to be less than, that means I need to be dividing it into pieces and not keeping all my pieces. I'm only keeping some of them, not all of them. Which means that I need to be multiplying by a number greater than or less than 1. All right, I need to be multiplying by a number less than 1. I cut it into pieces and I'm going to keep less than that whole. I'm not going to keep all of it, so now I have only part of it. So would A work? No, A is not going to work. A is more than a whole. That would be saying I'm going to keep the 505,786 and then a fourth of another piece of that. So the A is not going to work. Does B work? Right, B does work because on B, I'm dividing into fifths and I'm only keeping 2 of those. I'm only keeping part of this. So B does work. Does C work? No, C is a fraction greater than 1, which means I'm keeping a whole and then a little bit more. Does D work? Very good. Again, I'm looking for less than. D is a fraction less than 1, so D works. Does E work? Oh, got you there. E does not work because 18 is equivalent to 1, and when I multiply a number by 1, my answer is going to stay the same. So E does not work. Does F work? Right, F doesn't work. F is 4 whole, which means I'd have 505,786 times 4. It's going to get much larger. In fact, it's going to get 4 times larger. So that does not work. If you're collecting letters, that letter is U. It's going to be a longer word, just so you know. I want you to watch the whole video because I want you to be successful. So you have 2 letters already. Your second letter is U. Number 12, Mariah multiplied 48,972 by a number. Her product was greater than 48,972. Select all the expressions that have a value greater than 48,972. So she's multiplying a number by this, and we know that we're looking for something that's going to, her product to be greater. So if I want it to be greater, that means I need to keep all the parts plus some. So I need to be multiplying by a number greater than 1 whole. Does A work? Oh yeah, A does work because you're multiplying by 10. It's getting 10 times greater. That's quite a bit. It's definitely getting greater. Does B work? B doesn't work because I'm multiplying by a number less than 1, which means I'm not keeping the whole thing. I'm only keeping 2 of my 5 shares. So B does not work. Again, I'm looking for greater than. Does C work? Right, C doesn't work because 9/9 is equivalent to 1 whole, and when I'm multiplying by 1 whole, my answer stays the same. You guys are awesome. Good job. Does D work? Again, D doesn't work because D, I'm multiplying by a number less than 1. I'm only going to keep 14 of the 15 pieces, so D does not work. I'm looking for greater than. Does E work? Right, E does work because if I'm looking at E, I'm multiplying by a fraction greater than 1. This number is cut into 12 parts, and I actually have 14 parts, so I have the whole thing plus a little bit more. Does F work? Right, as well. F is a fraction greater than 1, so F will work as well. So your next letter is R, so that is your third letter. If you're collecting letters for your word, R is your third letter. Let's look down here. We've got a beautiful looking line plot. And on my line plot, it says, Noelle works at a pumpkin patch. Pumpkins are sorted by weight and recorded for inventory. The data of the pumpkin weights are recorded on the line plot shown below. Okay, so I have this line plot. Noelle wanted to compare the total weight of the 11 7/8 pounds pumpkins to the total weight of the 12 1/4 pound pumpkins. What are two expressions she could write? This should say to compare. See, I gotta edit my work. To compare the weight of the two size pumpkins. Okay, so I want to unwrap my word problem. I know that she wants to compare, which means greater than, less than, equal to, the weight of the 11 7/8 pounds and the total weight of the 12 1/4 pound pumpkins. I'm coming up with two expressions. One is going to be for the 11 7/8, and one is going to be for the 12 1/4. So 12 that she could use to, two expressions that she could use to compare my two weights. So I know I need one for 11 7/8, and I'm going to need a separate expression for this 12 1/4 pounds. So to find the total of 11 7/8, first I need to find 11 7/8 on my line plot. Oh, there it is. So if I want to find the total weight of 11 7/8, I'm going to look here at my frequency, and I can see that she had 1, 2, 3, 4 pumpkins that weighed 11 7/8. So I could do 11 7/8 and do repeat addition and add that 4 times, or instead I could multiply by 4. So that's one expression that she would write to compare. She would find the total of that. The other expression that she would write to compare is she would go to 12 1/4. So 12 1/4. And then count the frequency of how many pumpkins she had for that. So she had 1, 2, 3 pumpkins for that. So my question is not actually asking me to solve it. It's just asking me to write two expressions. So she would multiply that, and she would multiply that. That's all I need is the two expressions. If I were to solve it, I would do the same thing. I would take this and turn it into an improper fraction and then multiply by 4. I don't need to do that. So, but anyways, if I wanted to, it would be whole number times my denominator and then adding it to my numerator. Same thing here, whole number times my denominator, adding it to my numerator. Multiply times 3, multiply times 4. Okay, so we're on our fourth letter. So if you're collecting your fourth letter, we are now at K. So again, collecting those letters for your word. Let's look at the next one. These are two review questions that are meant to just help us stay fluid with our fractions and our past unit on adding fractions using a line plot, adding and subtracting. So this one says, what is the difference between the longest point and the shortest point? So difference is definitely an operation word, and I need to find the longest and the shortest. So difference is telling me to do what operation? Right, difference is telling me to subtract, and it's telling me to subtract the longest. So what number is representative of the longest? Oh, 13 whole. Now, what is noteworthy here with this is that I'm not looking for the frequency, I'm looking for the size. And so my longest size in this actually shouldn't be longest, it should be most weight. Heaviest, my heaviest is 13, and my lightest is, bing, bing. If you were here today, you would be going to RTI right now. I'm giving you RTI in a way, so. My least heaviest, my lightest is 11 1/4. So I'm going to essentially take 13 whole and subtract 11 1/4. The best strategy that I always give you with this is to rewrite that going vertically, making sure your place values line up, so whole numbers line up, fractions line up. So here I notice that I don't have a fraction, so I can't subtract 1/4 yet. What would I do to make sure that I can subtract 1/4? Because I can do it, just not yet. There's a step before that. Right, I would go to my whole and I would borrow from my whole, so my 13 would become a 12. And then I would take that whole and put it here. So what goes there? How many fourths is equivalent to 1 whole? Because I know it's going to have common denominator 4. Very good, 4 fourths. 4 fourths is equivalent to 1 whole. So the 1 whole I borrowed went there. And now I have 4 fourths. Take away 1 fourth. So now I'm just going to subtract my numerators. 4 fourths. Take away 1 fourth is 3 fourths. And then 12, take away 11 is 1. So when it's looking for me the difference between the longest or the shortest, or in this case, it should have been the heaviest than the lightest, my correct answer is 1 3/4, and my unit of measurement is pounds. So boom, got it. That is, again, a review from Unit 4 on adding and subtracting using a line plot. Here is your next one. What is the total of all the data points collected? So that means I need to take all of these. Now, the best thing about us in this unit now is that now we know how to multiply, so we don't have to do as much repeat addition. So I'm going to do this on a separate sheet of paper because there's just absolutely no way that I would get it all done here. So the very first one says 11 1/4, and there's only 1. So here's my separate sheet of paper. I've already done some work from the front side. So the first one says 11 1/4. And there's only 1, so I don't need to do any multiplication or repeat addition or any of that business. But I am going to put a little check above it so I make sure that I know that I didn't skip it. My next one says 11 1/2, and there are 2 of them. So I have plus, and I'm going to put a parentheses because I want to multiply this first before I'm adding. I'm going to multiply 11 1/2 times 2. Plus, I have 11 7/8 times 1, 2, 3, 4. 11 7/8 times 4. Now, again, you could do repeat addition if you felt more comfortable with repeat addition. You would do 11 7/8 plus 11 7/8 plus 11 7/8 plus 11 7/8. Teach his own. Dude, my alarm today. All right, so the next one, I'm going to check that off. I've done that one, is 12 1/4, and there's 3 data points. So I'm going to take 12 1/4, and I'm going to multiply it by 3 data points. So plus 12 1/4 times 3 data points plus 12 1/2 times 1, 2, 3, 4. So 12 1/2 times 4. Now, again, if you're watching this on replay as opposed to video, feel free to stop and take a break. Come back to this later if you want to, but please come back to it because you need to know it. I'm telling you, in middle school, you have to be able to do box plots. You got to be good at this before you can do box plots. And then the last fraction that I need to represent is just 13 whole. So now I'm going to go through and I'm going to multiply this. Some people will recognize that a 1/2 and a 1/2 will give you a whole. If you don't get that, no worries. So what I'm going to do is I'm just going to drop this down to create an equivalent numerical expression, 11 1/4, plus, now I'm going to take this and I'm going to turn it into improper so that I can multiply it by 2. So 11 times 2 is 22, plus 1 is 23. So I'm going to take 23 halves and multiply it times 2. So 23 times 2. 2 times 3 is 6. And 2 times 2 is 4. So now I have 46 halves. Plus, same thing here. Whole number times my denominator. Add it into my numerator. So 11 times 8 means I'm adding 88 eighths with 7 eighths. 88 plus 7. Let me think. 8 plus 7 is going to give me 15. And I regroup my 1. 8 plus 1 is 95. Okay, so 95 times 4. Whew. You know what? I'm going to save myself a little headache because this is going to be confusing. 98 fourths times 4. I'll come back and multiply it again. So you know what I'm going to do in this step is I'm just going to turn them all into improper and then come back. 12 times 4 is 48, plus the one I have is now 49 fourths times 3. Again, I'm going to come back and multiply them after I've turned them into improper. Whole number times my denominator, add it into my numerator. Now I have 49 fourths times 4. And then plus the 13 whole, I'm just going to drop down. So I took these ones, being smarter. I decided it's probably best if we don't skip steps and turn them into improper first, and then I'll go back and multiply them. So this I'm going to drop down 11 1/4 plus 46 halves. Now some of you will recognize that 46 halves can both be divided by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3, so that equals 23 whole. Plus, now here's where I need to multiply 95 times 4. If I can't do it here, find a spot over to the side and write it. 95 times 4. So 4 times 5 is 20. Drop down your 0, regroup your 2. 4 times 9 is 36, plus 2 more is 38. So now I have 380 eighths. I realize the number is big. I'm sorry. Hopefully it won't be that large on FSA. You never know. You never know. Okay, again, I need to do 49 times 3. So if I can't do it there, I'm just going to go over to the side and do 49 times 3. So 3 times 9 is 27. Drop down my 7, regroup my 2. And then 3 times 4 is 12, plus 2 more is 14. 147 fourths. Plus, and then here I'm going to do 49 times 4. Nine times 4 is 36. Regroup your 3. 4 times 4 is 16, plus 3, 196 fourths. Plus, oh, okay, so that one went there, that one went there. Well, I should have dropped those straight. It's kind of confusing. Boom. So now I can take those and see if I can add them all up, or I could regroup them, or what can I do with them. So this one I can't do anything with. 11 1/4 plus 23 whole. So I'm going to take this one and regroup it before I move any further. So I need to figure out how many times can 308 go into 380. So 8 can go into 38, 4, 5. Oh, 5 is too much, so that'd be 40. So 4 times, which means I'm taking away 320, 40 times 320. So 380 minus 320. I should have done this over the side. 380 divided by 8. And we said it could go in 4 times, which would be 32, which would leave me 60. So 8 can go into 60. Oh, 8 times 8 is 64. So 8 is too many times. 8 times 7, 56. And I would have 4 8s left over. And so 47 and 4 8s. Let's go that way. 47 and 4 8s. Plus 147 divided by 4. Let's see. Where do I have some room? I'll just go right here. 147 divided by 4. So 1 can't be divided by 4, but 3 can. 14 can. 14 can be divided by 4. 14 divided by 4 is 3, which means I'm taking 12 away. And I would have 27. That's not a 7, that's a 2. So 4 times what will get me to 27? 4 times 7 is 28. Oh, 28 is too high. So not 4 times 7. Let's do 4 times 6, which would leave you with 3/4 left over. So 36 and 3/4 plus, now I'm going to take 196 and divide it by 4. 4 can go into 19 4 times, which means you're taking 16 away. 19 take away 16, leaves you 3. Drop down your 6. 4 times what will go to 36, and that would be 9. 4 times 9 is 36, so nice, even, round, whole number with nothing left over. Thank goodness. And then 13. So now what I'm left with, I'm almost there, guys. Healthy struggle. It takes time, but it's nothing you can't do. It does take a lot of time. I'm not going to sugarcoat that at all. Now I can go through and I can add up my fractions and I can add up my whole numbers. So you only have 3 fractions, which is yay for that. So these are in fourths. This is eighths and this is fourths. So I have to have a common denominator. Some of you will realize that 4 eighths is equivalent to 2 fourths, and you could turn it into fourths. Most of you are not there yet. So I could turn them both into eighths. So 1/4 is equivalent to how many eighths? Right, if I multiplied times 2, I could do the same thing to my numerator. 1/4 is equivalent to 2/8. I'm just going to continue to drop all this down. This one's already in eighths, so I'm just going to drop it down. Here, again, I need to go from fourths to eighths. So what do I do to go from fourths to eighths? I multiplied by 2. What I do to my denominator, I'm also going to do to my numerator, which is going to give me 6/8 plus 49 plus 13. Whew! Again, healthy struggle, healthy struggle. Add your numerators. I've got 2, 4, and 6. So 2 plus 4 is 6, plus 6 more is 12 eighths. And then I still have all these whole numbers. So I'm just going to rewrite them going up and down because it's going to be too hard for me to add it in my head. And I'm going to draw a line so I make sure that my place value lines up. 47, so I've got 11, I've got 23, I've got 47, 36, 49, and 13. So this is easier for me to add that way. It's a lot of add-ins. So 1 plus 3 is 4. All these alarms, I'm telling you. 1 plus 3 is 4. 4 plus 7 means right now this is at 11. 11 plus 6 is 17. 17 plus 9 is 26. 26 plus 3 is 29. So when I add all these up, I got 29, but I'm just going to double check. I don't have time for errors. I got to make sure I'm right the first time around. So 1 plus 3 is 4. 4 plus 7 is 11. 11 plus 6 is 17. 17 plus 9 is 26. 26 plus 3 is 29. Perfect. So I'm going to drop down my 9 and regroup my 2. And now I'm going to do the same thing. I'm going to add my 10s. So 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 4 is 16. 16 plus 1 is 17. So I get a total of 179 as my whole number. Whew, that's a lot. So I'm here, which means I'm almost done, but there's one last thing that we have to recognize, which is that this is a fraction greater than 1, which means I can regroup it into another whole. How many times can 8 go into 12? Right, 8 can only go into 12 one time, so I'm just adding one more whole, and I'm subtracting 8 eighths, because 8 times 1 means I'm getting rid of 8, which would now bring my total to 179 plus 1 more is 180, and then 12 minus 8 is 4 eighths. And again, what do I know about 4 eighths? Whew, it's equivalent to 1/2. So your actual answer is 180 and 1/2. Unit of measurement is cups. So is it cups? No, pounds. So all the pumpkins weigh a total of 180 and 1/2 pounds. Again, it was a lot of steps to get there, but it's nothing you can't do. This is a great question because it's reinforcing lots of strategies. It's reinforcing multiplication. It's reinforcing line plots. It's reinforcing adding with common denominators, regrouping, all those great things. So your last letter, this is a 5-letter word. Your last letter is an S. It is actually meant to trick you because you probably thought you knew what the word was going to be, and I switched it up. So again, if you submit that for a treat as well, you now have 2 words, one for the front side, one for the back side. And I wish you all a happy holiday. Continue to study, do your best. And again, fast forward, rewind, do what you need to do. I will see you all back on Monday.